So in this video, what we're going to do is look at trigonometric functions when they're sketched. So hopefully what you can see here is three screenshots of three different trig functions. The first one is of sine, the next one is of cos, and then the next one is tan. So each of these graphs have a few features that are in common, and then obviously tan, as you can see, is quite different. And you'll see vertical lines drawn, and we call these our asymptotes. So with trigonometric functions, the graphs are continuous in cycles. So this is really important to remember, especially with your sine, cos, and tan graph. So because of this, we actually call them our periodic functions. We say they are periodic functions. If you're wondering what a periodic function is, they're basically graphs that repeat themselves continuously and they are cyclical in nature. So what makes them cyclical is the distance between the peaks and the distance between the troughs. So anytime we say the peak, we're referring to the maximum up here. So the distance between that peak there and that peak there is what we call a period. And then obviously the trough being down here. So the next trough will be exactly a period apart. So that's the distance we're referring to. While the graph of y equals tan of x is a periodic function, it also has asymptotes. So if we come back to the screenshots here, like I said before, the tan graph is quite different. It is periodic, however, it also has asymptotes, which is something the sine and cos graph don't actually have. The amplitude of a graph is half the distance between the maximum and the minimum values of a function. So if we come back to, let's say, the sine graph here, the amplitude is basically the distance between the axes there and the maximum. And that distance is exactly the same as the distance down here. And the same goes for our cos graph as well. Now our tan graph, doesn't actually have an amplitude, and that's because the amplitude of the tan function is actually undefined. And the reason it's undefined is because there's no maximum or minimum value. So another thing that's really important to understand is in order to calculate the period of a trigonometric function, we have a few rules we need to follow. So in terms of degrees, we can calculate our period for sine and cos by dividing n by 360. So n is the coefficient of the x term inside the bracket. So if we divide 360 degrees by n, we'll work out the period of a trig function. With a tan graph, we actually have to divide 180 degrees by n in order to find our period. If we're referring to it in radians mode, so here we're going to do 2 pi divided by n for sine and cos, and then for tan, it's just going to be pi divided by n. Another thing here is that when we're talking about the amplitude, it's important to note that the amplitude is always positive. So this is true even if a is a negative number. So if a is negative, all it tells us is that the graph has actually been reflected in the x-axis. The amplitude is still going to be a positive number. So for example, if you had the function y equals negative 2 times cos of x, the amplitude is still 2. All this tells us is instead of the graph going something like that, it's now going to be something like this. So there's been a reflection in the x-axis. Let's take a look at our first question here. So we're working in terms of degrees, or our domain here is restricted to 0 to 360 degrees. So we know that that's one full rotation. And we're told to sketch the graph of y equals 3 times sine of x. So what I like to do here is actually identify the key features of these functions. So the 3 first up is our amplitude. So that means our maximum value, or our maximum y value, will be 3, and our minimum y value will be negative 3. And it's a sine graph, so if we take a look at what sine graphs look like, it's going to start from 0, 0, and it's going to go up and then come down and go back up again. And that's pretty much it. So we've got one full rotation, so we know with one rotation we're expecting 2 x-intercepts as well. And another thing we should probably do is actually work out our period. So that just tells us how many cycles are within our restricted domain. So remember, to find the period of a sine graph, it's 2 pi divided by n. N is the coefficient of the x term, which in this case is 1. So that tells us that our period is 2 pi. Sorry, that's in radians. So it should be 360 degrees divided by n. So that means 360 degrees. We're going to have one full cycle with 2 intercepts within this restricted domain. So I'm going to sketch this now, and because you are starting out, you're encouraged to actually use your CAS calculator to help you sketch these functions. So I'm just going to have a go at sketching this now. Just bear with me. So now this is what our sine graph will look like. So some of the key features we know is, for example, that this is going to start at 0, 0. And we know that we're going through one full cycle with a period of 0 to 360. So that means that this value here will be 360 degrees, 0. Now, while you're starting out, I'd encourage you to use your CAS to find the other values. So for example here, our maximum y value will be 3. So this coordinate here is actually going to be 90, 3. This intercept here will be 180 degrees, 0. And this down here will be 270 degrees, and the y value will be -3. So what you can see here is that this here represents our peak. This coordinate here represents our trough. And if we're looking at drawing another cycle, so say for example my domain was from 0 degrees to 720, then I would essentially continue drawing this graph in exactly the same way that I have now. So just going to do the dotted line. And what that means is that the distance between this peak here and the next peak in the next cycle, that's where the period comes in. So one period, which in this case will be 360 degrees. So we can find that value there by adding 360 to the 90. Again, the y value will be 3 because we know with our amplitude, our maximum y value will be 3. So the next question has asked us to sketch the graph of y equals 2 times cos of x for a domain of between 0 and 2 pi. So here we're obviously working in radians, so I'm going to make sure that I calculate my period in radians as well. So to find the period of a cos graph, we're going to do 2 pi divided by n. So n again is our coefficient of the x term, which in this case is 1. So my period is going to be 2 pi, which means for this particular graph, it's just going to go through one cycle. And I'm going to have 2 x-intercepts here as well. Or I should be anticipating 2 x-intercepts. Another thing here is my amplitude is 2. So that means my maximum y value is 2 and my minimum y value will be -2. So now cos graphs are a little bit trickier to draw. Again, because we are starting out, I do encourage you to use your CAS to help you identify the relevant intercepting points. But for the purposes of this, I'm just going to do an introductory diagram, or a graph, sorry. So it's going to look something like this. So now this is what one cycle of a cos graph will look like. Again, my starting value here is going to be 0, 2, so I'll just label that the y-axis. My ending value will be 2 pi, and you can see here that it ends at the peak, so that's going to be 2. And my minimum value, which is down here, will have a y value of -2, and I've just done this a little bit ahead, so we know that our x value is going to be pi. If you are using your CAS, you can obviously use the minimum function or the min option to help you find the x value and the y value of this particular graph. Now again here, we can test our theory about the peaks, the distance of the peak, telling you what the period is. So we started with an x value of 0 and our graph ended with an x value of 2 pi. So that means that the distance between these two x values here is 2 pi. If we check our period, we actually worked out that the period was 2 pi, so we can see that we're correct. Which means, again, if this graph was to be continuous for another cycle, so let's pretend that it went up to 4 pi. So then my ending point here will be 4 pi, 2. And that means that this distance here should also be 2 pi, making that value there 3 pi, -2. So an x value of 3 pi and y being -2.